most annoying toy of 2017 was actually the key to deconstructing the universe. When you sync one of these glitter-infused little plastic rotors with a specific strobe frequency, the sky's rendering engine starts to fail. This isn't just a blur. It's jagged, low-resolution geometry, frozen edges, frame skips, the kind of thing you'd see if a video game ran out of GPU power for half a second. This isn't a toy spinning anymore. These are the seams of reality showing through. Here's the actual experiment. Take a fidget spinner and spin it up under a light source that flickers at a known rate. Old fluorescent tubes work. Certain LED bulbs work even better because a lot of cheap LEDs are basically strobing dozens of times a second without anyone noticing. At certain spin speeds, the blades of that spinner don't just blur into a circle like they're supposed to, they appear to slow down. Stop, reverse direction, sometimes they fracture into stuttering, multiplied ghost images like the spinner is being redrawn on screen one frame at a time, and the frame rate just isn't keeping up. Scientists call this a stroboscopic effect. Sampling rate versus rotation rate. The same reason a helicopter blade looks frozen on camera, or a car's wheels look like they're spinning backward in old movies. That's the textbook answer. Fine, but why does light itself have a frame rate at all? Here's where the boring explanation stops being boring. Physics already admits there's the smallest possible unit of time, something called the Planck time. A tick. A frame. The universe, according to its own rulebook, updates in discrete steps, not in a smooth, continuous flow. So, when a spinning object and a flickering light line up just right, what if this isn't an illusion? What if this is reality being sampled at close to its actual refresh rate? And for a split second, the smoothing, the motion blur, the anti-aliasing the universe normally hides behind drops out. And what's left underneath? Edges. Repeating ghost frames, geometry that looks like it was rendered by a graphics card that's about to choke. Low res. This effect has been filmed for years and dismissed as trippy or a cool camera trick. Slowed down strobe footage shows objects that don't just blur, they tile. They repeat in perfect little grid patterns, like polygons stacked on polygons, like the engine ran out of vertices and copy-pasted the last frame to keep up. Once this pattern is identified in the spinner, it starts showing up everywhere. Ceiling fans under cheap LED lighting, car rims on the highway at night, computer monitors fighting with phone cameras, throwing off strange scanline patterns on screen. What if these aren't glitches in the equipment? What if they're glitches in the render? Every one of these visual bugs happens at the exact intersection of two frequencies fighting for dominance, two clocks that don't quite agree. And in that brief window where they're out of sync, the smoothing fails and the underlying structure peeks through. This practice is sometimes called glitch hunting, deliberately searching for frequency mismatches between lights, screens, fans, and cameras because every mismatch is a tiny crack, a place where the simulation's compression breaks down just long enough to reveal the wireframe underneath. So, is reality actually low-res? Probably not. At least not in any way provable with a $5 toy from the bottom of a drawer. But the flickering geometry, the stutter, the tiling, the ghost frames is not nothing. It's a real, physical, repeatable phenomenon. It happens because something about how light and motion interact has limits, boundaries, a refresh rate. Once those boundaries are identified, they're difficult to ignore. The spinner was never the point. The spinner was just the first crack that became visible. The code behind the curtain doesn't announce itself. It flickers in for half a second between two frequencies that don't quite line up, and then it's gone again. Smoothed back over before anyone can be certain what they saw. Anyone with a fidget spinner and a flickery light bulb can run this experiment tonight. Results can vary depending on bulb type, spin speed, and camera frame rate. Share findings in the comments below. For more deep dives into frequency anomalies and perceptual glitches, subscribe!